Alright, this video is on the rules of exponents, so we'll be looking at everything from the basics to the multiplication rules, all the way up to the division rules. When we talk about exponents, just a brief review of the concept. An exponent has two parts in that expression, the exponent itself and what we call the base. So the base is what is being raised to the exponent. So in this case, it would be x. And then the exponent, of course, we know is the little number floating up in the corner. Now, there are a couple different things you can call this. Some people just call it the expression. Some people will say, x to the third or x cubed. Some people will use the word power to describe the whole expression. So that is the power x to the third. Other people like myself will use the word power interchangeably with exponent, just because, again, as I read, you would say x to the third power. So, like I said, there's that interchange there between the two words. So, in rules of exponents, we always start with the same rule, which is that we have to consider the base first. So again, just a little bit of review. What does the following expressions mean? Remember that an exponent is going to tell us the number of copies of the base that we need to multiply, and I'll use a little asterisk so we're clear about what that is. So if we have 2 to the third power, that means 2 times itself 3 times, as I read it 3. It does not mean 2 times 3. The answer is not 6. It is 2 times 2 times 2, which is 8. You can do this, of course, on a calculator as well. If it is going to be something that is a little strange looking, like 2 to the 0, we really have to consider what that means. So the number of copies of the base. Well, the base here is 2. And I want 0 copies of 2. Okay, so there's no 2's in that expression, but what do I write? And this question is a little bit complicated by the fact that we know if we have a 0 from multiplication, that means we have to multiply with 0. Okay, well, I can't say this is 0 because there's no 0 there aside from the exponent. So we say that 2 to the 0, or really I should say anything to the 0, is 1. And why do I say that? Because there are no copies of that base that we need to multiply together. There's no copies of 2 that we need to put into that expression. But we have to have something because it's not 0 itself, because we're not multiplying with 0. So we say that it is 1. For negative exponents, this is again a little bit strange because we can't say multiply 2 by itself negative 2 times. What does that look like? How do I write a negative copy of a number? Doesn't make sense. So we have a rule. We say if, and we use that to say the base, to the negative x power, we are going to take that and we're going to drop it down to the denominator. We give it a numerator of 1 and we say n to the x. Now, if we have this, then that makes it, okay, we're going to divide. Negative is the opposite of positive. Division is the opposite of multiplication. The opposite is also true. If we have 1 over, or any number over, n to the negative x, we bring it up n to the positive x over 1. So what I tell students in class is if you see a negative exponent, you always think about a number as numerator and denominator, even if the denominator is 1. So take that expression, that power with the negative exponent, and move it to the other part of the fraction. So if it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. So this one would become 1 over 2 to the second, or we also can say 2 squared. Okay? Now with this, there is one other rule, or I should say technique, I want to remind you of, and it is this. Parentheses and exponents are important because if I have something like this, negative 2 to the second, or negative 2 to the second. Now I say those the same way, but if you go to your calculator and put that in, one with parentheses, one without, you will see two different answers. The reason being, when you do this with a calculator, remember, calculators are not that intelligent. They can only do what you tell them. So when you have this in a calculator, it's going to do it based on the order of operations, which interprets that negative as a form of multiplication, which comes after exponent. So if I do this one on a calculator, this says negative 2 squared is negative 4. But if I have parentheses, I do the negative 2 times itself, which is negative times negative, which is positive 4. This is important, like I said, because you know negative times negative is positive, but this particular thing about the parentheses is important if you're not allowed a calculator, certainly, but also with the calculator, because if you put something in wrong, it's going to interpret it wrong, right? So make sure if you see parentheses, you use them when you use your calculator. Make sure that if you have negatives going around on your bases, use the parentheses when you're going to go to the calculator also. All right, let's take a look at some rules. So we have multiplication here. Okay, so two things. If you see integers, you can always multiply those integers together. 4 times 3 is 12. So just get that out of the way as soon as you get there. For the variables with exponents, what you want to do is you want to follow this rule. And I'm going to write it a little bit reversed of how I did before. Base a to the power n times base a also to the power m is equal to base a to n plus m. So if I do this, what this means is, provided the bases are the same, this rule only works if I have the same base, like I have both x here, I can take the two powers and add them together. So I would have x 4 plus negative 2 simplified is 12 x to the second. Now, why didn't I use the negative exponent rule that I showed you before? Quite simply because I didn't need to, because if I did the addition first, the negative went away. So that's my advice to you. If you're going to do this, then, and you see the negative exponents, do all your combining first using this rule, and the other ones we'll go through in a minute, and then after that, use the negative exponent rule if you have any left. All right, this one, okay, same process. I only have one integer, that's 4. Usually we will write our variables in alphabetical order, so x first. This first one is x to the 1 times y to the negative second. So if you have this, then you do not have that negative 2 applying to the x, unless there would be parentheses there. Okay, so if you don't see parentheses, assume the exponent only applies to the number or variable that it is right next to. And I'm going to show you something in the way that most textbooks will show you. X to the 1 times x to the negative 1. So we're going to move these around. Remember, we can do multiplication, whatever order we want, and put them together to make it easier to combine. Next is the y. So we have y to the negative second, y to the negative second, y to the negative third. So y to the negative second times y to the negative second times y to the negative third. Now we're going to do our addition. 4 x to the 1 plus negative 1, y to the negative 2 plus negative 2 plus negative 3. So we would get 4 x to the 0, y to the negative 7. Now I have to simplify using my 0 and negative exponent rules. X to the 0 becomes 1. So that would be 4 times 1. And you don't have to write that. If you want to just make it go away, that's fine. Negative exponents are not allowed. So I have to move that. We should think of this as being 4x to the 0, y to the negative 7th over 1. So I have to drop it down. Y to the positive 7th goes now into the denominator. So your final answer is that. You could also write this as 4 over y to the positive 7th. Again, you don't need to write that 1. Okay, some people just cross out the x to the 0. Right? Okay, you go ahead and hit pause and practice this one. And the answer here is 4a to the 5th c to the 5th all over b squared. So I did the rearranging just like last time. I added my exponents, getting me 4, because that was the only integer. A to the 5th, b to the negative 2nd, c to the 5th. B to the negative 2nd needs to move down because negative exponents are not allowed, leaving 4a to the 5th, c to the 5th in the numerator. B to the 2nd is now the denominator. Two things I want you to notice about this problem. First, when I did this at the end, notice that b to the 2nd was the only thing with the negative exponent, so that was the only thing that moved. The rest of the terms do not need to move. Their exponents are positive. The second thing I want you to notice, or I guess I should say a question that I want to answer, is some people will ask, well, do I need to do the rearranging, and do I need to write out that second line, I guess technically the third line, 4a to the 3 plus 2, and so on? The answer to that is no. You are perfectly fine to just look at the terms in the original problem and then combine the exponents using your calculator or mental math. That's fine. However, as a teacher, I always suggest showing more steps, not less. That way it's easier for you, and if you're a student, for your teacher to identify where you're making mistakes, right? If you just write an answer, is what I always tell my students, if you just write an answer, I don't know what you did. Did you make a mistake? The first step, the second step, the last step, did you copy it from somewhere? I don't know. So the more steps you show, the easier it is to see where we went wrong, if it is wrong. All right, we need another rule here for the next one. This one we will use the rule a to the n, parentheses to the m. See how we have that situation here? And again, this is just general speak for a rule. Has nothing to do with the m, that's our variable here. Is equal to the base a to the powers multiplied by each other. I want to explain this one in a little bit more detail than I did the last one. What this is saying is we want to take the expression m to the negative 4th and multiply it by itself 3 times, exponent included. Okay, so m to the negative 4th times m to the negative 4th times m to the negative 4th. If I combine those together, that would be negative 4 plus negative 4 plus negative 4. So that's m to the negative 12th, which is exactly what negative 4 times 3 would be. So that's where that rule comes from. And as before, negative exponents are not allowed. So drop that negative 12 down. 1 becomes the numerator, m to the 12th the denominator, and the 12 is positive. All right, why don't you take a second to practice this one? The answer here is 4u to the 2nd v to the 6th. As you may have thought to do, that exponent applies to everything in the parentheses, the 2, the u, and the v cubed. So that's why we get the second step, and then we simplify to get the last step. This is the rule that if I have a b to the power of m, I apply it a to the m times b to the m, and then you could say you continue c to the m, d to the m, whatever number of terms you have inside those parentheses. Okay, and then the same rule applies, multiply your exponents. Okay, I want to move on now to the division rule. Division rules, I think, are a little bit easier than multiplication rules in the sense that it gives us a little bit more freedom to move things around on our expressions a little easier. The rule for division, the basic rule that we're going to need in this one, is that if I have a power a to the m over the same base a to the n, then I can do that in one line as a to the m minus n. So if we're going to move this, we're going to subtract the exponents. Now, I can write it another way. Or, same expression, I could also write that as 1 over a to the n minus m. So wherever you want to put the expression, you're going to subtract the other exponent from that one. So if you want to put the expression in the denominator, you're going to subtract the exponent in the denominator minus the exponent in the numerator. So my suggestion, if the numerator is going to be the greater power, then you're going to do it that way. If the denominator is going to be the greater power, then you're going to do it that way. So the reason I suggest this, no negative exponents if you do that, right? If you always are going to subtract larger minus smaller. So in this case, the 4, I'm going to put our fraction bar in to begin with. The 4 is going to stay where it is, right? Because, well, there's no other numbers. And again, the numbers, you know, they obey these rules, but they kind of don't need to because you know how to divide numbers, right? So if you see multiple integers in the problem, just divide normally. And then, you know, if it's 1/2 or 3/4 or 4/1, you know, then you just put it where it goes. We're going to use the rules for the exponents. So for x, we have x to the third is bigger than x squared. So I'm going to put the x in the denominator, and I'm going to subtract 3 minus 2. If we have this one with y, 3 again is bigger than 2, so 3 minus 2 is going to be in the denominator. Notice that the 4 does not move. So we have 4, and then we have x to the 1, or just x, and then we have 3 minus 2, so we have y to the 1 in the denominator as well. And again, you could say that's 4 over xy. Okay, so division rule, basic version, subtract the exponents. If you are going to be doing that, you should always subtract larger minus smaller. All right, for this one, same idea. But this one is just x to the third over x to the 1. We know that we have 3 is bigger than 1, so it becomes the numerator. I'm just putting that over 1 so you can see it. You don't need to. And that would become x squared. Now, or x squared over 1. Now, with this one, again, the same thing that I had told you from before. If you have something like this, then you should, you know, more steps better than less steps. So you should show all the work that you're doing, but again, you know, it's certainly possible to do this subtraction, especially in one like this using mental math. So number 11, slide 11, is going to be something a little bit different. You can see multiple things going on here. We've got a fraction, we've got a power outside, we've got a power inside in the numerator. So 2 things you should do. 1, you're going to apply each of the rules in an order. So first, we're going to simplify inside the large parentheses. So we're going to simplify, I'm going to highlight the whole thing. We're going to simplify this part of the expression first. So just a couple things that I notice. So we have u to the 0. That's not going to do anything, so that can just go away. So the denominator is going to be v to the 4th. In the numerator, we know that we have the 3 should go to each of those terms, and we multiply our exponents. And I'm going to do this one with mental math, so you can see what that looks like. So we would do u to the negative 3 times 3 is u to the negative 9. And we're going to do v to the 3 times 3, v to the positive 9. And then we're still going to put our big parentheses and our second power because we're going to have to do that when we're done. Then we're going to keep going with that, and we see that we have a v in numerator and denominator. V to the 9th is going to be bigger than v to the 4th, so we're going to do u to the negative 9. And I know that you want to do something with that, but let's not touch it yet. So then we're going to subtract the 9 minus the 4, so that's going to be v to the 5th and a denominator of 1 for right now. Keep that big parentheses and everything to the second power. Now the second thing is to apply the rule that we have from before. And I'm going to make a slight adjustment to that to quote the rule because we're going to need it on the next problem. If I have a power a to the m over a power b to the n, everything to the p power, then I'm going to combine the rules that I know. So I'm going to apply that power of p to everything in that expression. So I'm going to have a to the m times p. I'm going to have b to the n times p in the denominator. So I'm going to do that here. So I'm going to see here that I have v. I'm going to have to go, actually I can make this smaller so we have room for our last two steps. So what I'm going to do is I'm going to do the 2 to the negative 9, so I have v to the negative 18. I'm going to do it to the v, so I have v to the 2 times 5 is 10. And technically I should do it to the 1, but I know that 1 to any power is 1. Now I'm done with all of my other steps, so last is going to be apply the negative exponent rule, meaning once you've done everything else, you know you're not going to get away from that negative exponent, so take v to the negative 18 and drop it down. Make that 18 positive and leave v, sorry, that is a u. This is what happens when you put u's and v's together. So u to the 18 is on the bottom, and v to the positive 10 is on the top. All right. Okay, go ahead and do this one. The answer here is quite simply y to the 1. So in this one, the two x's in our first expression canceled. Something divided by itself is 1, cancels, goes away. Y and y squared is larger, so in the denominator I will have the y. 2 minus 1 is 1. The negative exponent applies, so I have 1. Again, 1 to the negative 1 is just 1, so I'm just going to leave it. And then that becomes y to the negative 1 in the denominator. No negative exponents, and I've done everything else, so I have to use the negative exponent rule. Y to the 1 goes up to the top. All right, the last one I want to look at is just a very simple review problem from the beginning. And I want to go over just, again, if you have multiple integers. So just to show you that rearranging a little bit when you have different things going on. So we have one variable, and that's x. We have two integers, negative 2 and negative 3. So you should do negative 2 times negative 3, which is positive 6. This x to the 0, you can just ignore that as soon as you see it because you know that it's 1, it's going away. So you should just take the two x's and make that into an x squared. Okay? So again, 0 exponent rule, that should happen first because that's the easiest thing to get rid of something. Then you have to use the rest of your exponent rules. and then at the end use your negative exponent rule if it exists. Now, I do want to remind you again that the negative exponent rule only applies to negative exponents, not negative numbers. Okay, so -2 and -3, the integers stay where they're at. All right, thanks for watching.